Hi again, welcome back to the interaction system tutorial series. This is part 2. In the first part we covered creating basic interactions, picking up objects and stuff like that. So we basically were left with this kind of setup where we could start an interaction with a sphere and have it picked up by the hand. So it becomes parented to the hand bone here. So now we're gonna go a little bit further and see how what we can do with the ball once we have picked it up. So basically, first we should create a little script for the ball. We can just name it ball, and we add it to the sphere interaction object. So let's just open the script. Now first to begin with, just using root motion final IK. Let's also add using root motion demos. So how would this script know if the ball has been picked up? Here in this interaction object we have events, and this is our picking up event. We can here add animations and messages. So let's add a message here. Name the function whatever you need. I'm gonna name it on pick up, and for the game object, receiving game object, just assign the same one. So the ball script attached to the same game object would get this message. We can't directly send messages and animations to the character because the interaction object doesn't simply know which character it is interacting with, just because the interaction object is just a definition of the interaction and the interaction itself is being handled by the interaction system on the character. So we need to start by sending a message to the same game object. So back in this ball script, we make a reference to the interaction object, and we make this function that we defined here on pickup. So we're gonna do it void on pick up. So just let's test it. Debug log ball was picked up. Assign the interaction object. Start interaction, and we get the message that the ball was picked up, meaning that function was actually called. So, for example, if we just it might be that we need to change the holding position of the ball when the character has picked it up. We can do it by using effector position offset. So let's add an offset value. We're gonna offset the position of the hand effector when the ball is picked up. Then it will hold it in a different position. So just public vector 3 hold offset. Actually, let's make it a coroutine so we can blend in the weight smoothly. So you just change it to I enumerator. Get rid of this. So add a weight float hold weight. So while hold weight is less than 1, we're gonna just blend it in. Hold weight plus time. So basically, we have a coroutine that just gonna blend in the hold weight from 0 to 1. That's not quite enough for us because we have no use of this hold weight yet. So we somehow need a reference to the full body biped IK component and we can do it by just add it here. We can find it through the interaction object, just like that. IK is all last used interaction system. So the last used interaction system of the interaction object is the latest interaction system that used this interaction object. Get component full body pipe at IK. So now we can, using this line here, we can find the full body pipe at IK component on the character that is interacting with the ball. But that's still not enough. We somehow need to apply this hold offset to this full body pipe at IK. So we do that in late update. So as long as we don't have reference to the full body pipe at IK component, we can't do anything because the ball has not been picked up. So if IK is null, just return to nothing. In all the other cases, we can apply the offset just like that. IK solver left hand effector position offset plus hold offset times hold weight. So we can just assign this hold offset in the editor, and when the ball has been picked up, hold weight will be blended in, and that will give us this position offset here. So let's test this script now. Let's go to sphere ball. Now we have this hold offset value here. Let's just add a bit of offset so we see something. Start interaction, and we see that it's being held in a completely different position. So we can adjust it here. Now we see that actually this hold offset is in world space, so when we rotate this character we have a problem, so we need to use character rotation space instead. So we need to add IK transform rotation here. So now this value will be in the character's rotation space. Test it again. Start interaction. Let me find the ball again. Sphere here. So now actually we can rotate the character just fine, and we have this ball held nicely. What about this works nicely in idle animation, but let me show you. If I switch to some kind of walking animation, then it just might be not what we need, because the hand already has animation playing on it, and when we offset it might be not what we need. So instead of just this basic offset, we can actually use a component that's already included in final IK, and this component is being used by some other components like body tilt demo scene. It's called, let's replace this hold offset with public offset pose, hold pose. Just comment this out. What is an offset pose? Let me show you real quick. Add another component, offset pose. Effector links 1. Now we can assign the left hand effector, and we have some values here. First is offset, then we have pin and pin weight. add it here. And instead of this line here, we write hold pose apply solver hold weight and rotation space. So now when we play the scene, start the interaction, then we can use this offset pose here to say where we need to hold the ball. So again, this offset value works exactly the same as the one we used before. But if we have another animation playing, human walking, we can use the pin instead. Now, what is the pin? Basically, it is pinning the position of the hand to a position defined by this pin here, and that position is relative to the root of the character. So if we set pin weight on all axes to 1, you see something really weird, because the hand is being pinned to the pin position, which is 0, 0, 0. So we just move it up. So now we see actually this hand position is pinned to some place in front of the character. And actually we don't need pin weight to be 1 on all axes. We can set it to 0.7, for example. Then we can maintain some of that animation, not all of it, but just as much as we need. And we have a nice ball holding animation. So what if we need to drop that ball at some point? Now first, if we want something to drop, we need to have a rigid body and a collider sphere. So we also need to edit the script a little bit so the ball could be dropped. So we need to do it in update. Again, if we don't have the full body biped component, do nothing. So for example, if I press the D key, we start the dropping procedure. Start coroutine drop. Now we will define that procedure. It's gonna be a coroutine again. I enumerator drop. So the first thing we need to do is make the rigid body non-kinematic. We also need to set the parent to null, and then we can go ahead and blend out the hold weight. Let's just do it a bit quicker. So basically why we are doing it in update instead of late update, because at this point we are in a state where Mechanim has applied animation on the character, but in late update the full body piped IK has not solved yet. So actually in here the character is in its normal animated pose, so if we drop the ball from here, the ball will be dropped in the normal animated pose of the hand instead of the IK pose, which is holding the ball in a different position. But in update actually we are in, the ball is in the position where it was in the end of the last frame. So that's a lot better to do it from here. Let's test it. So we're gonna start an interaction and D to drop. And actually we can start the interaction again and drop it. So basically that's how it works. That concludes this tutorial. In the next one we're gonna take a look at I think we're gonna take a look at the animations, how do we trigger animations, and some clever tricks of doing complex interactions just with animating the target. And then we're gonna need to take a look at the interaction trigger component. So stay tuned. Until next time.